Yeah, so thanks for joining these sessions. My name is Martin. Joining with me is Siwan or Ivan. So today we will be bringing through some of this concept of containers and containers orchestrations platform. Yeah. With these current pandemic situations, I hope everybody is, keeping safe. Yeah. And then sit back and relax and enjoy these sessions. Yeah. Sorry for the late start because apparently there are some technical challenges. Yeah, so hopefully it will go well in the remaining of the sessions. So a little bit about myself. I am the solutions architecture manager for Malaysia. Right. So Ivan is our senior architect. So glad to be in this session. So let's actually get started. Yeah. So let's see. I hope everybody can see the slides. Let me see. I can navigate the slides. Seems that the thing is not allowing me to move. Let me try again. See whether I can actually share the screen again. Okay. So not everything goes well right now. Okay. Sorry for the technical challenge again. Yep, so for today's agenda, we plan to cover things like containers. So why container and what is container, even before that. So then having containers, if we have many containers, and then how we actually plan to manage it, that's where the platform comes in, right? So there are many different kind of containers, orchestrations, platform out there, in terms of choosing which one is the better ones. So we also look into some of the good characteristics. Yeah. So before we actually get into the other rest of the details, right, we need to look into the concept of containers. Yeah. So look at this picture, right? So if we look at it today, right, we want to be able to deploy our innovative services and our applications in the easiest fashion. Yeah. Nowadays, people are talking about digital transformation. Everything that we want to talk about is speed. Yeah. So how can we actually quickly go and from idea that we actually have, right? How can we actually quickly translate this idea and bring it to productions and bring it to our customers? Yeah, really fast. If you look at it, right, so just like the picture on top, so when we transport things over, and then we need to remember what is need to be in there, and the sequencing of how it's actually being loaded and unloaded, then in terms of rolling out the service itself, that will pose challenge, that will actually create a lot of waiting time, right? So how can we actually cut short this particular process? Yeah. So would it be nice that today we can put everything into one deployable unit, right? So then when we deploy these things itself, it's just like, at the dock itself, you put everything into a container, then you ship it to whichever platforms, whichever dock that you want, and then you just drop it there, then it will just work, without you needing to worry about all these dependencies, yeah. So if you put this kind of pictures into the software development world, right, so that is really the concept of containers. Yeah. Prior to the concept of containers, traditionally people have been deploying on virtual machines, right? So virtual machine is really talking about virtualizing a slice of the hardware, right? But after, even when we virtualize that, when it comes to deploying our services, our software, you also need to talk about understanding the OS, then from the OS itself, what are the libraries that we're using to develop and deploy the applications, and even the applications itself, even the versionings of the applications. All this itself, poses some of these challenges when it comes to virtual machine. Yeah. So containers in the other hand, on the other hand, right, allows you to say that even can we actually have further abstractions again? So this is where for all the applications, bits and pieces, the rest of the OS dependencies, if we can actually package it into something that we can actually drop, onto another platform, right? With the underlying OS being the consistent one, the application will just work by itself, right? So that's the whole concept of containers, right? By having that itself, it kind of like smoothen the process of the development, smoothen the process of the deployment. Yeah. So what's good from the infra perspective, what's good from the application perspective, from an infrastructure perspective, right? Always people talking about, the stability, so to speak. Yeah. So the capability to be able to scale, the capability to be able to be resilient, yeah, so that they can sleep better at night, right? So that is the concern from the infra team, right? From the application teams itself, can I just don't worry about the underlying infrastructure, then just let me code, right? Let me be able to just put in select freedoms to select whatever framework that I want, right? So when I deployed it, I just throw this bundle to you, and then infra you'll be able to kind of deploy this, without needing to always come back to me, So the bridge between this, right, is really the containers, right? So if the applications developer given the choice to be able to develop in the kind of language that they want, able to package it, then this package itself in the form of containers, right? Image itself, pass it to the infrastructure team just be able to actually spin it up and run. So that kind of like smoothen, the communications between the infra team and the applications team. Yeah. So with this itself, you may have heard of the word called DevOps, right? So the developers and the operations team, how can we automate the handoff between these two teams itself? How can we make it smoother? Containers will be able to be the middleman to help with this, right? So now that we actually understand a little bit about the container, right, and the advantage of doing container, so then how do we actually properly embrace the containers, right? So when there are many containers, when we are able to actually have the same container having multiple replicas of it, right, to be able to load balance each other, right? So what are some of the things that we need to worry about? Yeah. So these are some of the perspective I put in front of you. So needing to be able to talk about scheduling, right? So what do you mean by scheduling, right? So if let's say one container, the container rightfully should be able to deploy onto the underlying infrastructures, right? The underlying machines, the underlying nodes, so to speak. Yeah, scheduling that so that they can actually be able to optimize the underlying infrastructures, right? So that is the perspective of scheduling. How about the life cycle and the health, right? So how do we determine that this container, when it's actually spawned off in the infrastructure, whether it is healthy, whether it's serving the necessary performance that is required out of it, right? So those things will need to be considered as well. Security perspective, right? So when the container is running, so how do we actually handle things like the communications among all these containers itself, right? So how do we scale? How do we handle stateless kind of applications and stateful kind of applications? Those are the other perspective that we need to think about as well. Yeah, not to say for the infrastructure team, right? So we need to actually have a single pane of glass itself to be able to monitor all these running containers, right? So then, what is the solutions to some of this, right? So that's where, one of the very popular and proven kind of container orchestration engine, if you will, is Kubernetes, right? So Kubernetes is actually open source, right? It has been used and very widely, right? So many of the mission critical systems, right? So those like, for example, powering up some of these Google services, right? So these are all running on Kubernetes, yeah. So then just a little bit of slice and dicing the onion itself, a little bit deeper into what is this Kubernetes as a container infrastructures platform. So what does it do, right? So in the Kubernetes itself, right, so for a container orchestration platform, it can be run on the different kind of infrastructure, be it physical, be it virtual, private, or public cloud, right? So remember I talked about optimizing, yeah. So on top of all these infrastructures, this is where you can structure things like nodes, right? So these nodes itself can be sitting on all the underlying infrastructure as I mentioned below, right? So with these nodes, this is where the containers will be running in, right? So container is actually running in this concept called pods. So within the pods itself, you could actually have, if those two containers or these two containers itself need to communicate very closely with one another, tightly coupled, then you can actually put it into the same pod, right? So that's the concept of the pod and the containers. Yeah. So just to summarize, the containers run in a pod. The pod actually sits on a node. The node can be, hosted in the various platforms. Yeah. So underlying the pod itself, this is where the containers, yes, the containers is actually running. Now look at it as a cookie cutter kind of concept, right? So the running containers must be based on some kind of templates or baseline, so to speak. Those baseline itself is what we call the Docker image, right? So using the Docker image as the blueprint, then you spin off the container which is running in the respective pod, right? Now, then how do we actually monitor all this pod, right? How do we actually do the respective scheduling? So this is where in Kubernetes is how we actually have a set of masters, right? So you can see that it is not just one master, it's multiple master. What does that mean? It means that it gives you the resiliency, right? So the systems, the services is always up and running, right? So it has these particular features in there that allows you to first, do this necessary, role-based access, right, authentications, and whatnot. Those are functionalities in there, right? To say that when the user access the containers itself, then it is really the right being given the rights to access, right? So they are also schedulers that I've actually mentioned in there to actually be able to schedule, right? And based on some configurations to deploy these containers onto the various nodes, yeah. So you can see that then based on you can actually service things like, the MySQL, which is stateful, your database service can be running in as well. So you can actually run it based on the different kind of languages as well, right? So you can deploy Tomcat, you can deploy Node.js and what have you, yeah. So when the thing is actually running, you can see that we also have the concepts of the load balancing for your containers, right? So in this case, is how you look at it, right? So when you say that at any point in time, I don't want to actually have a single failure of my container rendering the service, so you can actually set it to say at any point in time, I want to actually have 3 copies of it running, right? So that is the concepts of having some internal load balancer, yeah. You even have the capability to actually specify that, can I automatically have that kind of auto scaling, yeah, when we actually have the demand in terms of the load. Yeah, so those itself is really handled by the management side of things. You actually have configuration. They say that how many services that you want to be available, yeah, to kind of load balance things, yeah. The other thing is that if one of the pod is actually ailing, right, it is not giving you the kind of response in the due time frame, right? So you need to have those kind of monitoring to allow them to be able to say that, well, we know this thing is in trouble. Can we actually spawn it elsewhere so that we still actually have the number of containers to service the workload while we are trying to, initiate the previous containers, yeah. So when it's up and running, then it can actually goes back again, yeah. So we also have the concept of persistent storage, right? That allows you to actually store data, yeah. So that data can be actually persisted in the platform as well, right? So having said all these things itself, hopefully you actually have a good understanding of when you know the goodness, the benefits of a container, then when we're deploying it at scale itself, you need to actually have a container orchestration platform. Yeah? So other than that, right, so to bring it to enterprise scale, what are the other features that is also required in there, right? So this is where we talk about other perspective. The other perspective is having the capability to have a single platform that able to service multiple projects, the concept of multi-tenancy, right? The concepts of being able to say that when these things is out, how do we actually handle all the ingress and the egress, the northwest and the east-west kind of communication, yeah? So is it also available for us to initiate something called the continuous integrations and continuous delivery, right? So bringing it towards the lab, whereby imagine that the developers when they check in the source code, the moment they tag it properly, then they can just initiate the deployment, right? So which brings you through the cycles of the auto build process. After build, then going through some form of what we call the automated testing, and from then going through some kind of governance process to even bring you the deployment to the various environments, right? So things like capacity planning, things like monitoring, things like vulnerability scanning. So it's quite important as well when it comes to all this, yeah. The other concept having this kind of platform is that to even cut down on the waiting time, you want to be able to give the people the capability to do self-service. So when we do self-service, then next thing comes to your mind to say is that, if I allow all these things, as I open the gate, so isn't it hard to actually manage? Don't worry, this is where the concept of quota management comes in, right? So given the quota, you are actually sitting in between to say allow the developers, the team to actually instantiate and create their own sandbox and their development environment, SIT, UAT environment with the given quota, and they will be able to just manage it and do self-service on their own, right? So those are the things that if the typical vanilla Kubernetes itself is not enough. The other, when you choose the enterprise platform, these are the perspective you need to think about. Yeah. So some of this I actually talked about self-service, right? Multi-language support, right? So in order for us to really innovate fast, so we shouldn't be limiting only to certain kind of technology. You need to be able to have different kind of support for different kind of languages as well. Yeah. Okay, so yeah, just give you a simple walkthrough of how the enterprise platform, having this capability allows you to improve your overall productivity. Just imagine today you just let the developer code. The moment that they actually check in the source code, right, then you through the CICD, you can even kickstart the build process. With the build process, conventionally people need to think about another build machine, right, whereby you need to figure out all these infrastructure needs to be able to do the build. So if would that be nice if to say that if the developers check in their source code, immediately the platform, right, create that kind of build environment for you, conduct all the build process. After the build process, the machines is no longer needed, then it's actually being thrown away. You can think of it as also another what we call a container service, right? Which is the sole purpose is for building, right? So once you build it, the container is destroyed. So that helps you to actually optimize your infrastructure, so to speak. Yeah. So once it's actually built, then it goes through the rest of the deployment process to deploy it into the rest of the rest of the nodes. Yeah, to service it. Yeah. So now we talked about the container, we talked about the orchestrations platform, also enterprise scale orchestration platform, what is required, and how do we even scale it? Yeah. So say for instance, this is going to be deployed in a kind of a geographic dispersed kind of situations, right? You may actually want to have different clusters, right? Different of your own container orchestrations platforms, but how do you actually maintain that consistency among all these various container platform clusters, right? So that's where the multi-cluster management comes in, right? So then also actually have some shared services, right, which is at the application level, right? People nowadays talk about wanting to have a place whereby we can roll out some of this, event-driven kind of platform, right? Event-driven kind of layers. Yeah. So this is where you can actually put that in as well. Yeah, to actually open it. Some even to say that, with this platform is nice, can we actually use this platform to roll out SaaS, right? Software as a service. Yeah. The answer is yes, right? So with that, we even need to think about other perspective. Yeah. Yeah, some of these other workload that we are expanding in terms of the container orchestrations platform is slapping on top of it the AML. Previous speaker talked about deepfake, and then how do we actually avoid that AML come into the pictures, right? So now AML, there are different what we call stages of it, right? There are data ingestions, there are the modeling piece, and there are also the publishing, and also the continuous what we call machine training and machine learning, right? So those things itself will requires really infrastructure to support it, right? Putting it onto a container platform, putting it onto a cloud infrastructure can really help you to scale. They can really help the data scientists itself having the self-service capability to really start their modeling fast, right? So cloud native native apps workload, right? And then even can we also take traditional VM kind of workload and put it onto this platform and orchestrate and manage it like how we manage containers, right? So that's where we actually talk about virtualizations on top of this container orchestrations platform as well. So that is also possible today. Yeah. So then, of course, talk about this platform, right? When you choose it, it got to be able to actually say that today I can run on my private infrastructure on premise. In the future, if I want to actually bring it to the cloud, am I able to actually do that? So then when you choose your platform, you ensure that those platforms that you have chosen is also able to work consistently across the rest of the public cloud service provider. Yeah. Right, so this is where we talk about the capability to support multiple languages, not only just that, the ecosystems, right? So the ISVs, right? So that they already provided some kind of software, right? So some kind of applications, right? So those things is right, moving forward, if we want consistency in managing it, so fully those applications should be able to run on this consistent container platform as well, right? So just to put this into the big picture, when you select a container platform, ensure that it has some of this capability that allows you to quickly translate from ideas to production fast. Yeah. So having told about all this, shared about all these concepts, yeah. So it's also good to see that can I see some example? Can I see something in play, right? So this is where I want to hand it over to my colleague, CY, yeah, CY or Ivan. He'll bring you through some cool demos on that. Yeah. So in this demo, I guess he will just select one of these platform to showcase some of this capability. Over to you, Ivan.
Okay, thank you, Martin. Yep. Let me
Let me
share
just
my
stop the sharing, and then you can take over the screen. Yeah.
yes, share screen. Screen one. Okay. Can you see my slide?
Yes. Yeah.
Okay. Yep. So I'll walk you through a very simple demo. So I'll be using a developer console, which is one of the features from OpenShift container platforms. I'll be doing deployment of Java applications. So this sample Java application is based on Quarkus framework. Quarkus framework is the latest Java technologies that provide you optimize of the resources but at the same time giving you higher throughput. Okay, so that is something that you may explore, but I'm not covering that in deep today. And if time permits, I'll touch a little bit on something called Cloud Native CICD, which is based on Tekton. Okay, so let me move to my demo screens. So imagine, I'm a new developer, just joined your organization the first day, right? So I'm being assigned a project, and this is the link to my project. So the source code basically is sitting in the GitHub repository. I also have the URL to access to the developer console. I have my login ID, password, and lastly, I was told that, I need to use some libraries that is pre-built and pre-prepared by the team, and I cannot just simply go to the public to download any of these libraries. And these libraries are actually sitting in the Nexus repository, and this Nexus repository is deployed in the same OpenShift platform that I'm going to use later. So let's take a look on the sample Java application I'll be using. So the name of this sample application is called Quarkus Podname. So like I mentioned just now, it's based on Quarkus framework, and this is a very simple API programs. It will return some greeting message plus the host name values. But in this case, I'm deploying into a container platforms. So it will return the port names value instead of host name. That's why I'm calling it this application as a Quarkus port name. Okay, so I'll need the URL to this source code. So I'm going to make a copy of this URL. Now, I'm going to log in into the developer console. So this is a Red Hat OpenShift container platform. It's a demo environment that we are actually hosting in the public cloud. So I'll be logging based on the ID and password provided. So the moment I log in, you can see I'm actually landing in this Topology Wheel. So this is the developer console that I was talking about. It's specially designed as an interface for developer purpose to do their development and also deployment, right? So there are a few options here, which I'll come back and walk you through this, because the deployment will take some time, right? So let me go ahead and choose these options from Git. Okay, so this will allows me to import my code from a Git repository to be built and deployed. So the first thing I need to fit in is a Git Report URL. So this is where I paste the URL I copy. So if you notice, the moment I paste the URL, this platform actually does a validation against the URL. It will try to access the source code from the URL, see is it accessible or is it a valid URL. Okay. At the bottom here, you can see there are some advanced Git options you may further fit in if you need to. For example, if you are pulling the source code from different branches or different tabs, this is where you can put in the value. If it's within a subfolder, then you can put in under this context directory. And the last one, source secret. So this is used to store your ID and password, right? So there could be a situation where you may using private repository and you actually need an ID and password to actually access the source code. So you'll be creating the secrets here. At the same time, the system actually detected what kind of programming language in your source code. So in this case, you can see the system actually successfully detected the programming language and is recommending the builder image, which is representing by this star icon. So you can see automatically it has chosen as a Java builder image to be used and compile for my applications. So at the same time, you can see there are other options here, right? So let's say you are building your application using .NET Core, Node.js, or even Python. So this system actually does support the developments and also the compilation of all these different programming languages. So this is a truly polyglot platforms to host different type of applications based on different languages. So further down, I can choose the builder image versions. So in this case, this is a Java builder image. In a way, I'm choosing the JDK versions to be used and to be compiled along with my source code. So I'll just choose JDK 11. For the application name and also other component names, I'll just keep it standard so that all the names being used will be standardized. For the resources, there are 3 different resources type I can choose to be used to describe how my application should be deployed. Okay, the first choice, deployment. This is something that natively come with naked Kubernetes. While the second one, deployment config, this is something that only available in this enterprise container platform I'm using. So the difference is that it has different kind of features from each others. For example, deployment config support version control. Every time you make some changes to these deployment configurations, then the system actually will make a copy and then keep track the versions. So at the point of times, you can easily just roll back to the previous deployment based on the last configurations, while deployment does not have these features. So that's one of the example. And the last one, which I'll be using today, which is a Knative service. So according to the description here, it's a type of deployment that enables serverless scaling to 0 when idle, right? So in other words, when there's no traffic or no workload, the system actually helped me to scale down my application to 0. That means there's no active running instance. So there won't be any consumption of either CPU or memory or even network bandwidth. Okay, so this kind of capabilities applies a lot of benefit, especially like development environments. Right, as a developer, maybe I doing my jobs like starting from 8 until 6 or 7 p.m. But during night times, actually there's no active development activity at all. Right, so based on these options, the system actually will scale down everything I've been working daily into 0. Then the next morning, when I come back to work, when I start logging in, making some API calls, then the system will bring back the application live to serve whatever traffic it needed to be. Okay. Then I would like to add a pipeline. So this is the cloud native CICD I was talking about. So I can just easily tick these options, and out of the box, it will give me 3 different steps, or we call it tasks. So the first one, it will actually fetch the source code from a repository where it actually is doing a Git clone. Then it will continue to do compilations and image building. And the last step will be deploying the output, or so-called the container images, as a serverless applications. And here I have the options to create a route. So basically this is to expose my application to a public URL so that any of the external parties can consume my API. There are some other advanced options here, but I won't be going through them in this demo. So let me go ahead and click this create button. Okay. So at this moment, there's nothing deployed yet because I was choosing using the pipelines. So if we go to the pipelines, you can see there's some activity that is running here. Okay, but I'll need to go ahead and stop this. The reason is because I want to make use of this Java libraries, which is coming from this internal Nexus. So I need to actually fit in this into part of my pipeline so that when it comes to the build process, it will actually pick up the libraries from this pre-prepared Nexus. Okay, so I go ahead and edit the pipeline. So I'll choose this build. Over here, you can see there's options input form for Maven mirror URL. So this is where I'll paste the URL copy for the Nexus tree. Okay. So at the same time, you can further enhance your pipeline if you want to have further steps like doing some code scanning or image scanning or some unit tests in between. Right. So the one out of the box provided by the system when you creating the pipeline is these 3 default steps. Right. You can further enhance from here. Let me go ahead and do the save. And then I'm ready to kickstart my pipeline again. Okay, I'll leave every options as default and start it. Okay, so it should be taking a while, probably a couple of minutes. So while this is running, so let me go back to the developer console. Okay, so over here, we have a lot of items or options here, right? We can choose from how we want to deploy our applications. I was choosing from the Git. Okay, if you are new to these platforms, you can actually pick some of the quick starts here to go through some tutorials, some guides or steps to actually familiarize with these systems. It provided some sample applications for you. Okay, and we have other deployment choices here as well. For example, if you would like to deploy from a dev file, or is maybe your colleague already built some container image, you want to directly pull that image and deploy into your own workspace. This can be achieved by choosing this. Or if you have your own Docker file, you can supply this to have the system to build according your Docker file steps as well. So others, we have YAML, databases, Helm chart as well. So there's one big catalog here. Let me go inside here. So inside this catalog, there are 148 items here. On the left, you can see they are breakdown into different categories. So we have CICD here. You can see the item listed here are Jenkins. But you know, just now I was choosing the pipelines, right? So that is the a cloud native CICD that is powered up by Tekton, while Jenkins is more of like a traditional kind of a CICD. But we are still supporting this Jenkins in this platform as well. If you want to use Jenkins, you actually can choose this template to deploy a Jenkins server in this platform itself. We also have other items listed under databases. So out of the box, it provides you MariaDB, MySQL, Progress, and under languages, we have similar like what I've shown you when I did the deployments. So we support .NET, Go, Java, JavaScript, Perl, PHP. We also have others middleware software that can help you in your totality end-to-end of your projects. Like for example, to do the analytic and also data. So for example, if your project needs some caching mechanisms, you can actually deploy these data virtualizations to help combine different data source and then build a virtualized data layer in between. Okay, and if you are looking for something like cache services, in-memory caching, you can go with data grids. Okay, so there are others like for integrations. So we have API gateway here. We have AMQ brokers. We also have Apache Kafka in these items, and there are process automation runtimes and others. And the last one is others. So those items categorized under others actually are coming from our partners or our ISV. All these are certified solutions from all our partners. So it's not just only the Red Hat components. We also have a very huge ecosystems around this platform that can give you different kind of solution you needed. Okay. And on the left side, let me quickly briefly go through the menu you can have here. So for monitoring, it gives you a view of all the workload in terms of the resources like CPU usage, memory usage, receive bandwidth, transit bandwidth. You know, as a developer, traditionally we do not have this kind of informations, right? We are not able to access this. While with using these platforms, it actually automatically capture all this information for me. So as a developer myself, I can monitor how my application behave, right? In terms of the CPU usage or memory usage, I can easily even find out is there a memory leak in my application if I just leave my application here idling running for some times, and I just observe the graph whether is keep on increasing, and then there could be some memory in my applications. So I also can do some searching for other resources. Okay, this is the build, then this is the pipeline, and then we support Helm chart deployment. This is looking from the perspective of all the projects I have. Similarly, you can see the CPU and memory usage, config maps, secrets, and so on. Right? So it looks like our pipeline has finished running. Okay. So if we go back to the topology, yep, we should see that there's a application up and running. Okay. So when your mouse over this, you can see one is running. So there's a little icon here. Oops, you can see the system actually is scaling down because there's no workload. Okay, so this is the beauty of the deploying our application as a serverless resource type. Now let me click on this little icon here to open the URL. So this will make a call to my API. So at the beginning, it may take a while because the system actually was scaling down. Now, the moment I created some traffic there, the system immediately bring another port or so-called another instance to serve my need, right? So you can see it's actually returning some reading message. Hi, IO Foundations from the, this is the port name. It is quite long, right? So we have Quarkus port name PKY and ending with KSN 85. Right, let's do a double check, see whether is this the correct port name. Yep. So it's the same name that showing in the return of my API. Okay. Now, one more thing I want to do is that I would like to automate this pipeline to be triggered, right? The moment I finish my coding, then I do a commit and check into my Git repository. I want to set up something called a webhook. Okay. Before I can do that, I need to add something called trigger in this pipeline. So I'll add this one. I'll choose my Git provider type. So in this case, I'm using GitHub. Okay, so I like to capture the push event. That means whatever source code I committed, then it will actually create a push event and trigger my pipeline. As for the rest, I just leave it as default. After I added this trigger, if I go back to check the details of my pipeline, immediately here you can see there's a trigger templates created, and there's a URL here. So this is the URL for the GitHub to actually notify this pipeline to kickstart the process in order to pull the latest source code I have and starting all the tasks here, and then help me to build, deploy into my environments. So I copy this URL. Oops. Let me go back. Right click here, do a copy of this URL. Then I'll go to my GitHub. So I'll be creating a webhook over here. Okay. I'll just go ahead and delete the existing one so that I can in a new one. Okay. Let's start from a new one, adding a webhook. So paste the URL I just copy. Okay. And the content type my system will be receiving is a JSON. Okay. Just push the event. Alright. Active. Now I go ahead and click add the webhook. Okay, it's been created. Let's take a look in there. Recent deliveries. Yep, there's a green tick here. So this indicates that it's a valid URL for GitHub to actually push the event to my pipeline. Okay, so in order to simulate this, I need to do some code changes and commit, right? So typically you will be using your own IDE, your preferred IDE tools, development tools to make the code changes and then push into this repository. But for this demo, I'll just go ahead and make the changes straight away from the GitHub. Okay, so probably I'll just change hi to hey everyone. Okay, so let me go ahead and commit this. So once I commit these changes into the GitHub, according to what we planned, it should kickstart my pipeline, the CICD that I was using just now, right? So let's go back and verify. Yep. So it's currently running right now. So the moment this finish, then the message here will be changed to the latest changes I have committed into my source code repository. Okay, so this is how I've been using this very nice, very easy to use developer console to do my deployments. So I touched a little bit on about the these pipelines, which is the cloud native CICDs based on the Tekton project itself. Okay, so that concludes my demo. Okay, let me. Okay, so for those, if you would like to play around with these OpenShift platforms, right? So you can go to this learn.openshift.coms. There are different.
Siwan, there's
Yep.
a questions, yeah,
Oh,
that
okay.
is populated. Is centralized logging available out of box in OpenShift?
Yes. So let me go back to my OpenShift environment to show you. So if I go back to my topology again, okay, so I can probably choose this sample application I have here. Okay, so here I have a few informations here that are about my deployments. At the moment, I cannot see any port here because there's no resources, no traffic yet. So I need to trigger another API call. Okay, so the system will bring back one live instance. Then we can see there's an active port over here. And on the right side here, there's this view logs, right? So if I click on these view logs, okay, so you can see I can see the log messages without accessing to the VM or so on and so forth. I can just use this web console to access the logs, and I can do some expand if I want to see in a bigger view. Okay, if I want to download the logs, I can do so. I also can view in a browser manner, right? So in terms of the development side, you don't have to do any specific coding or configuration how the logs should be. You can actually just flash all your messages into the standard output, and then this centralized logging within these systems will actually pick up all the loggings and shown in this console. Yep.
Seems like questions are all coming in right now. Can we have manual decisions on deployment once the webhook is triggered?
Manual decisions on deployment.
I guess the question goes along the line is like, can we add another task, right? That says that, let's say when we promote to UAT or from UAT before we promote to staging, there are some approvals required. So can we do those kind of things?
Oh yes, definitely. Remember when I was showing when we doing the edit of the pipeline?
Mm-hmm.
Okay, so we actually can easily modify the task that provided by default, right? So for example, I want to add here. Maybe this is a concurrent task, and I can choose one of the tasks I have here. Okay, so you can add some so-called approval tasks in betweens to allow some manual interventions to actually do some sort of like approval before it move to the next task. Okay.
Okay, cool.
Yep.
All right. Looks like, we have keep the questions coming, but meantime, CY, I figure that you have created some interesting quiz, right? For the audience to really do a quick knowledge check.
Yep.
After that, for those who answer correctly, probably you have some mystery gift to give away, right?
Yes. Sure. Yeah. So if you want to try it out, you can go to this one. Okay. To try some scenario case. You also can request a sandbox. Like your own these enterprise platforms to play around if you love to. Okay. Yeah, so let's go with the quiz. Okay, so we will be doing a fun quiz now. Okay, so you must answer faster and also the correct answer to get higher score. Okay, there will be total of 5 questions. You will have 20 seconds to answer for each questions, and we will pick top 5 winners, and these top 5 winners will get 20 ringgit of Grab food voucher. Okay, one thing to take in mind is that when you register for the quiz later, please key in using your valid email address, because this voucher will be sent to your email address. Okay, in case you have typo or anything, do not worry. Just leave a message in the chat, or you can PM either me or Martin. Then we will follow up with you later to get your valid email. Okay? Right. Without further ado, let's go ahead and show the quiz. Yep. So you can, if you are using your mobile device, you can scan the QR code to access this quiz. If you are using your computer browser, you can just type the URL of this slido.com, slido.com, and you will be asked for a code to join this quiz, right? So the code for this quiz is IOF and 0717. Okay, IO Foundations and today's date. Okay, let me activate the quiz. So the moment you join, you should be seeing your email address appear here. Okay, so we will probably wait a couple of minutes, to have the participants to join into this quiz. Okay, we have one participant, John. We have 3 now. Okay, for Linux Geek and also Mike, probably later after this, please stay back a little while. We would like to capture your valid email address so that we can, if you won the quiz, we would like to get your email address and send you over the great voucher code. Okay, so we have 4 participants now. Okay, maybe we give another 10 more seconds. Let's count down from there. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, any last call? If not, then I'll proceed with the quiz. Okay, remember the one answer faster and with the correct answer get the higher score. Okay, get ready? Let's go. The first questions. One or more containers are running as a unit of pod, server, or virtual machine. Okay, time's up.
Oh,
Wow.
very good.
Everyone picked the first choice. So let's see what's the correct answer. Okay, good.
Right.
Everyone got the right answer. Okay, ready for the second quiz? 3, 2, 1, go. Which of the following is taking care of pod placements? Data store, scheduler, authentication. Time's up. We have 25% of the participants choosing data store and 75% choosing scheduler. Yep, the majority got the correct answer. Right, let's move to the next one. 3, 2, 1, go. Where does a container image store at? Okay, so after you build your images, so where does, typically these images will be stored? Is it in etcd, image registry, or authentications? It's a very simple questions, right? And everyone got the correct one. Great. 3, 2, 1, go. Which of the following is available in Vanilla Kubernetes? Okay. So, out of these 3 options, there are 2 actually is not available in Vanilla Kubernetes. Okay. So we have one choosing, we have 25% choosing source to image and 75% choosing config map. So the correct answer is config map. So if you are, using those Velina or Naked Kubernetes, right? So you will get some of these out of box, like for example, config maps. While source to image S2I is something that only available in OpenShift platforms that actually simplify the deployment of your application. For example, just now the demo I was using, underneath actually when it does the compilation and building process, it actually is using this source to image as part of the technologies. Okay, so here comes the last questions. 3, 2, 1, go. How many tasks or steps were used in the CICD during the demo? Okay, so while I was demoing the cloud native CICDs, actually how many steps were there? Or how many tasks? Yep, again, we have 100% choosing 3. Yeah, everyone got the right answers. Now, let's see who is the winners. Ta-da! Woo! We have this mingfei.hua@gmail, and Mike is the second, Linux Git, and Ryan. Okay, congratulations.
Congratulations. Yeah.
Yep. So for Mike, Linux, and Ryan, maybe you can catch us, in this table here. So after these sessions, you can actually go to the lounge, and then you go to this the table 5 here. Okay, both Martin and myself will be there. So maybe we can capture your valid email from there, so that we can email you the grateful vouchers. Okay, so if you guys would like to get in touch personally with either Martin or myself, so here is the linking link at the bottom here. Right, you can add us into your LinkedIn, then you can private message us from there. Okay, so we will be moving to this table 5 here. If you have any more questions, any inquiries, feel free to take a seat there. Right, thank you.
Okay, thanks everyone. Yeah, hope everyone actually have a nice day ahead. Yeah, and stay safe. Yeah. So see you in the lounge later. Okay, shall we go to the lounge? How to go there?
All right, thank you, Martin, thank you, Tan.
Okay,
that was really quite informative. I have split attention, but I'm listening on both ears. Actually, I have 2 earpieces on. I'm listening on both ends. It's actually quite interesting. Thank you so much.
No worries, no worries.
All right, I think we will just end